In this video, we'll be finding the extrema of a function on a closed interval. The first step that we'll take is to find the critical numbers. We do that by letting the derivative equal 0. So that's the first thing that we'll want to do is find the derivative of our function and set it equal to 0, and then solve for those x values. These x values then are called the critical numbers. Now, critical numbers also occur when the derivative is undefined. So we need to keep in mind that if the derivative is ever undefined, then at that x value, you'll have a critical number as well. Our second step is to evaluate f of x at each critical number. Then we want to evaluate f of x at the endpoints of the interval. Since I'm finding the extrema on a closed interval, I'll have endpoints at the left and the right. And then the least value of f of x is the minimum, and the greatest value of f of x is the maximum. So let's do an example. In this problem, we're asked to find all extrema for f of x equals x cubed minus 27x in the closed interval from -7 to 5. Now we know that this is a polynomial, and the graph of all polynomials is a smooth, rounded curve. So we won't have any points where the derivative is undefined. We just need to do a derivative. So our first step is to find the derivative. That will be using the power rule, 3x squared minus 27. Then we're going to set the derivative equal to 0. Let's add 27 to both sides. And divide by 3. And it looks like x is equal to plus or minus 3. Right, so these are our critical numbers. All right, our next step then is to evaluate f at our critical numbers and then at our endpoints. So I'll want to find f of 3. I'll want to find f of -3. I want to find f of -7 and f of 5. Now I'm going to use my graphing calculator. We can do it quickly by entering our function into our calculator. So we have x cubed minus 27x. And then I'm going to press enter, and I don't know what number will pop up, but let's store 3 into, so 3 store x, and then second enter, and that brings our function back up. Now, since I stored 3 into the memory, the x memory, now when we evaluate this function, it'll do so with x equal to 3. So it looks like -54 is what I get when x is 3. Next, I'm going to store -3 in. So -3 store x. And the store button is right here. That's how you store it in. So -3 is now stored in my calculator. as my x value, and then second, and take your finger off, enter, second, enter, and I have my function back. So when I press enter now, I'll get the value when x is -3. Looks like 54. Right. Now I need to store -7 in, store x, and then second enter, and enter. So -154. Oops. -154. And then let's store 5. And -10. This is my only positive value, so it looks like the point -3, 54 is an absolute max. And -7, -154. Now -7 is at an endpoint. So this is going to be an absolute minimum. And this is an endpoint, so the only thing I can say about this one is that it's a relative minimum. Now, if we take a look at that graph, cubed minus 27x, and I want to do it in the window from x equal -7 to x equal 5. And it looks like my y minimum, I want a -154, so let's put -155. And then my y max, 54, so we'll put 55. Go by. Graph there. Now this is my closed interval from -7 to 5. I can see that I have a minimum here. It's an absolute minimum because it's on the endpoint. And this is a relative min because points on either side of it are all higher. So we can call that a relative min. And then this one we would call an absolute max because it's the highest point in that closed interval.